Hello everyone, my name is Nina.
My name is Sharon.
It's great to be here today.
Did you know that a small change in the shape of the wind turbine blade can make a big difference in how much electricity it produces? It looks simple, but the design of each blade is important for capturing wind energy. Have you ever wondered why we don't see wind turbine with square blade?
There is actually a scientific reason behind it, and it all comes down to how air flows around different shapes. The topic of blade design has sparked my interest because even small design changes can lead to big difference in energy production.
Today I'm going to talk about how blade shape affect power generation. The focus of my talk today is on comparing 4 different blade shapes and finding out which one produce the most electricity. We choose blade shapes as our variable for 2 main reasons. First, it is easy to control. We can keep the material and the weight the same for every blade. This way, we know that any change is only caused by the shape.
Second, there are many possible shapes. We can test different designs, such as rectangles or triangles. This helps us discover which shapes spin faster and produce more power. This topic is really important because wind energy is a clean and renewable energy source. If we can improve blade design, we can improve energy efficiency and generate more electricity. I will focus on 3 main parts. First, our experiment design, then our data and results. Finally, our conclusion and source of error.
So the first point is our experimentation setup. Our independent variable was the shape of the blade. We test 4 shapes: traditional windmill type, fan type, and square type. Our dependent variable was the amount of electricity generated. We choose which we calculate by multiply the current by the voltage.
To make sure the experiment was fair, we control several variables. For example, we control several variables in the experiment, including the number of blades, their thickness, the material used, the magnets, the wind speed of the electric band, the distance between the fan and the generator, and the time we started collecting data. Each blade shape was tested 3 times to improve reliability.
Now the next issue concerns how we analyze our data. These graphs show that the fan-shaped blade had the highest average power output. In this table, we can see the average results. Windmill type 20.08, fan type 78.74, traditional 40.91, girl type 12.99. Clearly, the fan-shaped blade produces much more electricity than the other three shapes.
Similar research also shows that larger wind-facing area can capture more wind energy. However, our original prediction was different. We originally thought the order would be traditional windmill, fan, and then square, but it turned out to be fan, windmill, traditional, and then square. From the standard deviation, only the fan-shaped blade show a clear difference. The other three shapes had overlapping standard deviation, which means their difference were not very significant.
The next point I want to explain is why this happened. A fan-shaped blade has the largest wind-facing area. When the wind-facing area is larger, the blade can receive more wind. The wind turns the blade and generates electricity. However, because the electric fan has a fixed radius, the wind only spreads within a limited area.
Therefore, making the blade longer does not always improve performance. Instead, increasing the width of the wind-facing surface within the fixed radius can capture more wind and keep the airflow longer. That is why the fan-shaped blade produces much more electricity than the other blade shapes.
Lastly, I want to cover the question of experimental error. One possible problem was that we did not perfectly control the fan and control the angle between the generator and the fan. This may have caused difference in wind energy received.
Another issue was equipment error. During the experiment, the generator had connection problems, and we had to replace it several times. Also, we could not perfectly control the weight of the blades. Different shapes naturally had slightly different weights, which may have affected rotation speed.
To summarize, today I explained how blade shape affect power generation. We test 4 different blade shapes under controlled conditions.
The central point has been that blade shape significantly improves electricity production. Thank you for listening.